In this video, I'll show you how to work with triangle congruence. No, these will not be full-blown proofs, but it will lead you to the necessary steps to be able to make your own proofs. So triangle congruence is basically one of the heart of the things you do in geometry. You've learned a few things at this point in whatever geometry class you're taking, and things start kind of coming together. So basically there's four ways that you can show triangles are congruent. You've got SSS, SAS, AAS, HL. Okay, so these are all abbreviations. This one meaning side, side, side. This is side, side, angle, hypotenuse, leg. So very important to know that HL is for right triangles only. So whenever you have right triangles, you can think, okay, well, it's possible that this is going to be, if they are congruent, maybe by HL. This also very important. There's no AS. That's right. So however you want to take that, it's true. For triangle congruence, there is no ASS. So with this in mind right here, plus some other tools that you may have learned, and if you didn't, reflexive and vertical angles play a big part in this all throughout. All right, so let's show whether or not the triangles are congruent. If they are, state the proper congruence. Okay, so just by looking at this triangle, I'm looking at the setup that they gave me here. All this stuff is given to me. So what's given to me is that AAC is congruent to AB. And I've got that this is a right angle here, and this is a right angle here. So these are two right triangles. So essentially what I have is triangle ADC and triangle ADB are right triangles because they have right angles in them. So since I have right triangles, I'm automatically thinking I'll try and use HL. I might be able to use a different one, but my automatic reaction is going to be, let me see if I can make this work. If I can't, I'll try some of these other ones. And if none of these work, the triangles are not congruent. Okay, so first thing that I can notice right off the top is that I have something with AD. Well, this side AD, I can write the following statement. AD, segment AD, that's what this line over letters means. It means segment, is congruent to segment AD. So this side right here from, say, this triangle is congruent to this side. That's part of this triangle. Now, there's a property that I covered in another video that says that we're allowed to do this. These are two triangles sharing a side. So obviously this side is congruent to itself by the reflexive property. So this is not something that will go away. You're going to need this in geometry. Reflexive property. Okay, so now that I've shown that this side is congruent, I can make a little mark through it. I've already used the two marks here and here, so I can just use one. I could use three. It doesn't really matter, as long as it's different from these right here. So if I'm going to try and make this work as a congruence using HL, I have to make sure it is work. It actually does work. This side is the hypotenuse. I know that because it's directly across from the 90-degree angle. Hypotenuse is always directly across from the largest angle. So my hypotenuses are congruent. And the leg that they share, that is also congruent by the reflexive property. So this one has triangles that are congruent. So let me write it as triangle ADC is congruent to triangle AD, oops, ahead of myself there, ADB by HL. So this one turned out to be two triangles that are congruent by hypotenuse leg. So that's the first one. That's how you're going to go through all of these. Okay, let's look at a few more. I've got a couple more for you. So let's go to the next one that I have. Okay, you're going to see two on here. I'll go through both of these on the same page. All right, so I'm given this setup right here. I've got this. You're going to have something very similar to this when you're doing these. It's up to you to look at it and know what to do. So I'm given that angle A over here is congruent to angle E. All right, I'm given that this side, AC, is congruent to EC. Okay, so the only thing that I can see to do right now off the top of my head is that I have this happening right here. Angle ACB is congruent to angle DCE. So let me explain what's happening here. I see that these are two triangles that are basically touching at this point. And I see that this angle right here and this angle right here, they look like they're opposites and they're sharing this point. So I covered that as well in another video, that if you have an angle like this and it's sharing, like, say, a point with another triangle and those angles are opposite of each other, then I know that these angles are congruent. I'll go ahead and mark it. These angles are congruent by vertical angles. So that, again, is something that you have to be able to look at and immediately recognize, oh yeah, I've got vertical angles happening here. Okay, so with that in mind, is that enough for me to say that these are congruent? Let's take a look and see what we have. I've got an angle, a side, and an angle. Okay, so it's very important, just as on a side note, this is really, really important that you don't miss this, that you stay within one triangle at a time. Look at what I'm doing here. Side, angle, angle. See what I just did there? I went from this side that's part of this triangle, this angle that's part of this triangle, and then I said, okay, this angle that's all of a sudden part of this triangle. You cannot do that. Do not do that. You have to stay within one triangle at a time. You can compare two different things like this, but make sure you go in a consistent manner. This angle, this side, this angle. And in fact, that is a congruence. So I can now go ahead and name these triangles. Doesn't really matter how you do this. I'll call it ACB. And I'll say it's congruent to triangle DCE. And I know this is true by angle, side angle. Okay, so that one worked out by ASA. And so, again, this is a process you are going to go through every time that you see these. Look for stuff that you can fill in based off of what you're given, and then just look at it. Okay, so angle here, side here, angle here. All right, so let me just make sure that matches. Does this other triangle over here go angle, side, angle? Yes, it does. So we're good. This works by angle, side, angle. Okay, next, I'm given this diagram. I'm given that C is MP of segment BE. So here's segment BE right here. What does MP mean? Midpoint. Super important in geometry that you see this and you automatically know what this means. So if C is the midpoint of BE, this automatically means that this side is congruent to this side right here. Sorry about that, guys. Lost my flash. So I'm going to have a little shadow down here. I'll try and compensate a little bit. It won't come back on. Phone's pissed off at me. Anyways, so you have to know right away that if you have a midpoint of some segment, that automatically tells you that this midpoint is going to cut whatever it's a midpoint of, in this case BE, in two equal parts right here. So I can go ahead and fill in those tick marks because this is a midpoint. Okay, so based off of that information, let me go ahead and look at these triangles and see if I have enough to make some kind of a, congruent statement. So I'll just start, say here, angle, then another angle, and then side. So I stayed within one triangle when I did that. Angle, angle, side, that's all within this triangle. If I come over here, am I able to do the exact same thing that I just did over here? Angle, here's another angle, here's a side. Yes, I am. So I can go ahead and say that these two triangles, name them however you want. Let's just go say triangle BAC is congruent to triangle EDC, and I know this is true by angle, angle, side. I know it's like this wants to be ass, but it's not. It's like ass. But that's allowed, it's just ASS that is not allowed. So, okay, I've got one more example to show you. This one's kind of a good one. Not really terribly difficult, but it does illustrate very well how to look at this and know what to do. Okay, I've got a triangle. I've got, let's see, AB is congruent to CB. I know that because of these single tick marks here. I also am given that this point D, I didn't write that down, but point D is the midpoint. So let's make a note of this real quick, that D is the midpoint of segment AC. Okay, so since D is the midpoint of AC, automatically I know that D cuts this whole thing into two congruent parts. So there's that. And I also know that these are two triangles that are sharing side BD. So anytime you think sharing a side or sharing an angle, this is what I can go ahead and say, that BD, so side or segment, whatever, that's fine, is congruent to side BD by, there's a property that tells me that if two things are being shared by a bigger triangle made up of two smaller ones, or if it's an angle, that's fine too. That's the reflexive property. So make sure that you are good with that stuff because you're going to need to know how to do that. Okay, so since BD is congruent to itself, I can go ahead and mark it as congruent. I use 3 because I've already used 1 and 2. You can use 4. What the heck, I'll use 4. It doesn't really matter. Okay, so now that I have that done, I'm just going to look at this, and obviously you can see that I can go side, side, side. I stayed within one triangle, so that's good. Can I do the exact same thing on the other triangle? Side, side, side. Yes, I can. So that means these two triangles are congruent by side, side, side. So ultimately, these take practice. They take practice to be able to get these. Sorry about the shadow. Once again, my phone is pissed off at me. It's really hot. It won't turn the flash back on. So they take practice to be able to get good at them just by looking. Make sure you know your midpoints, that you can fill in stuff like this really quickly, your reflexive properties, and your vertical angles. Thank you so much for making it through all 14 minutes of this. I'll see you guys next video. Bye.